Good morning, students. Welcome in video lecture of electronic devices and circuits. Today, we are going to discuss the unit number 1, JFET. Already, we discussed in previous lectures related to the semiconductor devices, then semiconductor material, the components which are made by the semiconductor material and its application. All these things we are discussed about. And in previous, that means in the last lecture, we discussed the entire syllabus of this particular course. That means electronics devices and circuits. And related to that syllabus, what are the exact objectives and what are exact the course outcome of this particular course we are discussed now. That means we already discussed this thing. So today, by considering that point of view, one more thing I want to share with you people that this particular subject, it carries 60 marks for the theoretical examination and 40 marks for CA1, CA2 and mid-sale. So it carries total 100 marks. So we remember all these things, and whatever the CO and course objective, that means course objective as well as the course outcome, I introduced in the previous lecture, that just remember all these things and then go through the entire syllabus related to this particular electronic devices and circuit. Now, today we are going to start exact the unit number 1 JFET from this syllabus, and from that first point, or you can say the topic here I want to start here, is the introduction to JFET. So as per the syllabus point of view, the first topic is the introduction to JFET. So already we discussed the electronics components, the semiconductor materials which are used in the electronics industry to develop the various components. That thing it is developed discussed one. By considering that point of view, I am going to start this particular first point, and this JFET, it is nothing but it is the junctional field effect transistor, which is made by the semiconductor material having the three terminals. Its operation, it is based on the controlling of the input voltage. That means whenever you are applying the input voltage, you are controlling the entire operation of this particular, you can see that JFET. We'll discuss that thing in the coming points as the it's working and all that thing. See, this JFET, it looks like a simple transistor, or you can say that it's a bipolar transistor. I said I used the word simple because this is the first transistor which is introduced. That's why I used the word simple, but it is not a simple, it is a bipolar transistor. They are appeared as very similar, right? But there is a difference in the form of the operation. That bipolar transistor, it works on, or it is said that it is a current controlled device, and JFET is it is controlled by input voltage, right? So this is the difference. That means BJT, it is the current controlled, and whereas the JFET, it is controlled by the voltage. Okay, so in this introduction, the this JFET, it has mainly two types. Its main type, I'm not going to directly introduce the junctional field effects types. I'm considering the JFET. So the JFET has the main two types as the junction field effect transistor, JFET, and second one is the metal oxide semiconductor FET. It is also called as the IGFET or MOSFET. In short, it is called as the MOSFET. Now I will explain once again what is the exactly bipolar, and then I will go for that particular JFET. So bipolar transistor, its output which is considered at the collector side, okay, it is directly proportional to, or it is proportional to the input current which is flowing through the base terminal of that particular device, right? And that's why it is said that it is a current operated device, because if there is a very small change in that particular current, it causes that particular large load current to be switched on, or you can see that there is a switching in the large load current. That means in BJT, whatever the base current it is carrying on, there may be smaller current, or as per that particular consideration of the application, that current it switches that particular operation of the entire BJT, and that's why it is current operated device, which is considered for the smaller change in that particular, or smaller current can also use to switch the large load current, right? See the word, it is smaller current can be used to switch a large load current. Remember that thing. That's why it is called as the current operated device. Now, if I consider the field effect transistor, then field effect transistor, it is a voltage operated device. That means at the input side, at the input terminal, this particular device it is applied with the voltage. That means input side in the sense gate terminal, right? So gate terminal it is applied with the voltage, input voltage, and that gate terminal it controls, or whatever the current flowing through that, or voltage applied to that particular gate terminal, it controls the whatever the current flowing through that particular channel in the sense from the source to drain, or you can see that drain to source, because whatever the you can see that majority carriers are there, that majority carriers it flows from the source to drain, and that's why we are saying that the electrons or majority carriers holes are flowing in the direction from the source to drain, and then again to whatever the power supply is applied, okay, according to that, and back to the source again to the drain, like that it is the inner loop, right? So here it controls that particular flowing of the current through that channel. So if I said that majority carrier, but if we are thinking about the conventional current, then it is from the drain to source. So that gate voltage it controls the whatever the drain to source conventional current is there, that is controlled by this particular gate terminal, and which is proportional to the input voltage, right? Which is proportional to the input voltage. Okay, see the operation whatever it is happened in that particular FET, it is relies on that electric field, and that which is generated by the gate voltage, and that's why it is called as the field effect transistor, which is voltage operated device, I just shown this symbol here of the transistor, or actual transistor, how it is looks like one. It is having the three terminals. See, three terminals. I am not sorry for that. I am not explaining that exactly three terminals. Just I will explain here. It having the source, then drain, and then the gate terminal. Like this, it is having the three terminal device. Okay, we will see exactly how it is constructed and all that thing in a construction part. So you will get the idea about this particular JFET. Now, again, just whatever I discussed by considering that point of view, I will continue with that point as the junction field effect transistor. Its functioning of that junction field effect transistor, it depends on the flow of majority carriers in that particular channel. See, channel in the sense that may be N channel, that may be P channel, we will see that channel. So that majority carriers may be electrons or holes, depends on, and that function that means function of this FET is depending on that particular majority carriers, and that majority carriers are controlled by the gate voltage. Remember that thing. Now JFET consists of an N-type or P-type silicon bar containing PN junction at the sides. That means at both sides the if suppose you are considering the n channel bar, then at the both side you will get that that particular FET it is having the p type silicon material, and due to that p type and n type, that junction it is happened at the side of that particular, you can see that JFET. So some sort of the important points to remember related to, just I said that this is the gate, source and drain terminal it is considered. So I will discuss that particular thing, so that how the transistor it is considered, you will get idea about this thing. Now, how the gate it is defined, that means you can see that manufacturer one for that particular transistor, or you can see the diffusion it is done, so that gate terminal it is, you can see that consider for that JFET, we'll see that thing. Now, as I said that gate, source, drain, these are the terminals, and the material by you which you are made the transistor, that is nothing but your N type or P type, that is called as the channel. So we'll discuss that particular thing. Now gate. By using diffusion or alloying technique, that both side of the bars, that may be N type, that may be P type, are doped to create the PN junction. Suppose you are having the N type bar, then you are using the another material as the P type material, and by using that P type material, you are diffusing P type material on the N type, and you are creating the PN junction, right? And this doped region is called as the gate, right? Now, at the both side of that particular bar it is considered. If suppose you are considering N bar, then P type material you are using for the diffusion, right, to create the gate terminal. If suppose you are using the P type bar, then that particular N type material it is diffused on that particular bar to create the PN junction, so that you will get the two gate regions on that particular channel. Now source. Now the source terminal, it is nothing but it is the entry point for that particular majority carriers, through which the entire they enter into the semiconductor bar. The entire majority they will enter in that particular semiconductor bar. That is nothing but source. That's why it is called as the name as a source. So majority carriers are entering in that particular bar. Drain terminal, it is nothing but it is the point which is called as the exit point for the majority carriers, through which they leave the semiconductor bar. That means they are leaving that semiconductor bar. That point it is called as a drain. And channel, it is the area of N or P type material through which majority carriers are passing from the source to drain. These are the main four important points related to the JFET. You have to remember this thing, so that you will get the entirely idea about this particular JFET. Now, I already said that field effect transistor, it is having the main two types as the JFET and MOSFET. Now we'll see the exactly the types of the JFET, and I mentioned here construction, that means types of the JFET and construction, but detailed construction we'll see in the next video lecture. Just how the channels are there, which types are there, and how the channels are created, how the JFETs are considered. By considering the channels, we are going to discuss here, but the entire construction we will see once again in detail in the next lecture. Now there are two main types of the JFET commonly used in the field of semiconductor devices. These are N channel JFET, P channel JFET. So remember that there are two main types. Now in this slide I shown the N channel. We will start with the N channel as the first type of the JFET. The N channel, it has the thin layer of N type material, okay, and which is having the two P type substrate which is formed the of that particular side of that particular n-type material. So the entire n-type bar which is considered here, it is having the at the side of that particular 2p-type substrate. I said that this whatever the gate it is developed one by considering the diffusion process or alloying technique. So here figure shows the both symbol as well as the exact how the n-channel JFET it looks like. So here P, right, gate terminal it is shown here, and P material it is the substrate which is added, or you can see that diffused on that particular N bar, right. So the gate is formed on the top of the N channel with the P-type material, right, and the ends of the channel and the gate lead wires are attached, and substrate has a no connection, right. Substrate has the no connection. Now see here, drain it is leaving, which is through which the majority carriers are leaving one, and source terminal it is the entry point of for that particular, you can see that this JFET for the majority carriers. So this is the N channel. We will continue with that particular N channel in next slide as the here I shown one figure in the form of the how the, you can say that current it will flow, and that particular depletion region how it is increased by applying the gate voltage that I just shown here. But in operation we will see exactly details about it here. Here whenever source terminal it is connected with the DC supply or DC voltage with the considering the drain lead, then maximum current it is flowing through that particular channel. At that time, if we are saying that gate terminal it is not connected with anything or it is kept open one, okay, the same amount of the current will flow through the source and towards the gate drain terminal, okay, and this whatever the current it is flow through this particular drain to source, it is depends on the applied voltage between the, you can see that source and drain, between the source and drain, and this is again determined by the VDD and its internal resistance of that particular, you can see that channel. Now typical value of this particular drain source to drain resistance of a JFET is quite a few hundred ohms. Okay, it is clear that even when the gate is open, full current conduction, just I said that, will take place in the channel, and essentially the amount of bias voltage applied at the ID controls the flow of current carriers passing through the channel of the JFET. Okay, now when you suppose applying some sort of the gate voltage, then the whatever the current it is flowing through the drain to source, it can be controlled by applying the gate voltage. That means very small changes in the gate terminal or gate voltage, that means that gate voltage is applied in between the source and the gate terminal, right, and whatever the small change in the gate voltage, it again controls the flow of that particular drain to source current, right, and also so you can say that it can be controlled anywhere between the full conduction and cutoff state of that particular JFET. That means whenever the transistor it is in a full operation, that means in a full conduction configuration, okay, and that situation and the cutoff state, that situation, in between that you can control the current flow in that particular JFET. So this is all about the N-channel JFET. Now again, by considering the second type, that means a P-type JFET, or you can say that P-channel JFET, here the P-type material it is used to form this transistor, JFET transistor, by considering the N-type substrate. That means here P-type bar it is used one, and the N-type substrate are diffused on that particular sides of that particular bar, and so that that PN junction is formed, and this PN junction or whatever that area it is diffused one by using the N type, it is representing as the gate for that particular JFET. In that figure, I shown the symbolic representation as well as the exact how it looks like with the connection and that particular terminals I shown in that particular figure. Now, at the end of this channel, again, gate terminals are connected to each other, and the wires are attached so that two whatever the types are there, that is considered one. And rest construction details are similar to the N channel. No, there is no any doubt. Now, exactly the operation is also some kind of the same. Only the polarity as per the source to drain and gate to source. That polarity it is changed during the connection of that particular P channel JFET in the circuit. So, in general operation, the gate terminals is made positive with respect to the source terminal for this particular P-type material, and the PN junction, it depletion layer, it depends upon the fluctuation in the values of reverse biased gate voltage, whatever the gate voltage it is there, because again you are considering the positive terminal to the gate, that means N type material is connected with the positive voltage and P it is considered with the negative. That's why what this junction it is get reverse biased, right? And due to that, whatever the depletion region it is again done one, depending on the whatever the current it is flowing from the source to drain, it is, or whatever the majority it is carrying from source to drain, it is controlled, right? That is the thing. So, and this control it is happens in between, again same to that particular N channel as the conduction, in between that conduction, full conduction at the cutoff state, right? So figure shows the exactly how this operation of this particular, or how the connection of this particular P channel JFET it is made one. So here I shown that drain, that means D terminal, it is connected with the negative terminal of the power supply, and source it is connected with the positive of this particular power supply. That means drain to source, it is connection, it is shown here, and source to gate connection with that particular battery or power supply, it is shown as the source it is connected with the negative terminal and gate it is connected with the positive terminal. And here how the depletion region, that means at the junction it is created one, that is also shown in this particular another figure. So this is the entire about the P channel. The operation of the P channel, it is similar to that particular N channel JFET. So this is the all about the you can say that JFET as per the consideration of the introduction of this JFET and its type. I just explained how the JFET it is form one, and how the JFET it is having the terminals, what exactly the consideration for the JFET is there, and how it is constructed one. The construction I said in a very brief one. In next lecture we will discuss in detail the construction as well as the working of that particular JFET. Once again, might be I will repeat the types of that particular, because these types of the JFET it should become after the you can see that explanation of the construction of the JFET, because the construction, once the construction it is done one, then after that particular types of the transistor it should be considered one. But that thing I will again maybe in next lecture I will consider that thing once again. But here today we discuss the once again I am repeating this thing. Today we discuss the exactly what the mean of this particular JFET. Remember that I am repeating that particular point. BJT it is the current control device, whereas this JFET is the voltage operated device. It is also similar to that particular, that means JFET is appear or looks like the similar to that particular you can see that BJT, but there is a difference of this thing. Okay, then here one bar P type, either P type or either N type bar it is considered, and at the sides of that particular bar, the diffusion process it is made by using, suppose you are using the n-type bar, there p-type material substrate it is used to diffuse on that particular sides of the n-type bar, so that that gates can be diffuse the area, it is called as the gate terminal, and so that the junction can be created in this particular JFET. Right, so this is the thing. And by considering that point of view, which type of a material, semiconductor bar, it is also called as a channel, right? Okay, depending on that, the types of the, you can see that JFET, it is class done one. That means P type and N type, N channel or P channel JFET, it is said one. Here, from source to drain, that majority carriers are flowing through that bar. That means source terminal it is nothing but it is the entry point for the majority carriers, and drain terminal it is nothing but it is the exit point for that particular majority carrier. Okay, remember that thing. And gate, I said that gate it is nothing but it is the diffused region of that particular substrate. That is the thing. Then I just discussed the how the JFET it looks like and its type, and that means N channel and P channel, and the symbolic representation that I just explained here. So remember this thing. If you are having any doubt or if you want to know about more about this particular JFET, you can call me at any time or you can ask me anytime, and I will share that thing with you. So thank you guys, and study well, and be safe in your home. Thank you.